Now in this video we'll be discussing on a routing protocol called RIP. Now in today's networks, RIP is not used, and even it's no more part of the CCNA syllabus as well. But again, it's one of the basic protocol which was used for implementing the routings. So we'll start with RIP. RIP stands for Routing Information Protocol. It was one of the earliest protocol which was used for implementing the dynamic routings. Now the basic feature is it's a standard protocol, open standard, which means you can run this protocol on any Cisco platforms, on Cisco devices, as well as you can run them on a non-Cisco device. It's a classless protocol which is not going to carry the subnet mask information. As we discussed in the previous session, classless means it's not going to carry the subnet mask information along with the updates. And when it is sending any update, it is going to simply send as a broadcast via out of all the interfaces. An update received on one interface simply send out of all the remaining interfaces. And the metric in RIP will be hop counts. Now metric is a measurement or the unit which is used in deciding the best route. So let's take an example. I got a router A connecting to router B, and then we got some routers here, and then I got 5 routers here. So I got some names here, router A, router B. Let's give some names for the routers here. So this is router A connecting to router B, and I connect to router C, router D, and router E. Now in this scenario, if I just take an example, if I want to go from A to E, from router A to router E, there are 2 possible routes. Now one of the possible route is I can go via ABE. That is one of the first possible route. So I got a router ABE, that is one possible route here. As per the diagram here you can see. Another possible route is I can go via ACD. So there are 2 possible routes, either I can go from 8BE or I can go from this route. Now in case of static routing, administrator will decide the best route. If I configure the next hop address as B, always that route will go from this route. But in case of dynamic routing, who will decide the best route? The router. The router is going to decide the best route with the help of some protocols. In my scenario, I'm going to use RIP protocol, Routing Information Protocol, and it has its own calculation, and it will see the number of hop counts in the path for deciding the best route. So it will see how many hops we have from this side. There are 2 possible hops here. You can see 1 hop and 2 hops. Hops nothing but the number of routers on the path. And then the other route, this route is having 3 hops, that is router C, router D, and router E. Now one of the route is having 2 hops and the other route is having 3 hops. So whichever the route is having the least number of hops, that route will be considered as the best route. Now in this scenario, the router is going to decide the best route, and it will see the least number of hops. That's what we call as a metric. Metric is actually the value which it is going to use for deciding the best route. Now what if there is one more link connecting between the router A to D? Let's say there is one more link here, and now in this scenario, if I want to go from A to E, there are 3 possible routes. One is ABE, the other one is ADE, the one which I just connected here, ADE, and the other route is ACDE. So if I'm going from here, how many possible hops here? Here there are 2 hops, and from this route there are 2 hops, and then from the third route I have 3 hops. Now whenever a router come across a scenario where, now in this there are 2 best routes, right? So the least is 2 and there are 2 possible routes, and both are considered as a best route, and it is going to do something called load balancing. So if a router come across a scenario where if it learns about the same destination via multiple routes, and here there are 3 possible routes, and out of these 3 possible routes, these 2 are the best routes and both can be the best routes, so it will do something called load balancing. The load balancing means using both the routes, forwarding one packet from here, other packet from here. So in case if a router come across a scenario where it has multiple best routes, it will do load balancing, and it supports up to 4 equal paths for load balancing. Okay, so by default the router is going to decide the best route based on the hop counts. That's what we discussed just now, and it will do load balancing if it come across a scenario where it has multiple best routes. And one of the major drawback with the RIP is maximum hop count. It supports only up to 15. So which means 1, 2, 3, the maximum hops it supports only up to 15. So 16th hop is unreachable here. 16th hop will be unreachable. So including my router, I can go up to 15 routers, which means including my router, it will be 16 routers. So if your network size is 16 or less than 16, RIP is more applicable. So that is one of the major drawback with the RIP. It's not applicable for the big size networks. It's only applicable for small size networks. Administrative distance is 120. I'll be getting into this administrative distance more in detail in my next videos. Probably right now I'm not going to discuss this one. And it's going to exchange the complete routing table for every 30 seconds. So if you remember, in the previous distance vector protocols, it will work based on periodic updates. So for every 30 seconds, it is going to send the update to the neighbor router. Like in my scenario, if I just take down here, the router A sends an update to router B for every 30 seconds, and the next update again it will send for every 30 seconds, for every 30 seconds, for every 30 seconds there is an update. So RIP works based on periodic updates. That is also one of the major drawback in case of RIP. So let's try to understand the next thing. So we'll be discussing on RIP timers. Just now I discussed that RIP sends periodic updates. Now what are the different timers, or what is the time interval it is going to use for sending the updates, and what if the best route goes down, how long it is going to use for using the alternate route. So by default there are 4 timers in RIP. The first timer will be the update timer. Update timer is something sent for every 30 seconds, and by default every router is going to send update for every 30 seconds. The router A sends an update to B 30 seconds, and the router B is going to send update for every 30 seconds. Every 30 seconds, 2 routers send and receive the updates. What happens if there is a link failure? Right now, what happens if there is a link failure? In that case, I'm not going to receive the update, right? So in case if there is a link failure, the router is going to get into invalid timer. 31st second, it enters into invalid timer. And how long it will be in the invalid timer? 180 seconds. So which means already 30 seconds has been finished here. It's going to wait for 150 more seconds, where in the invalid timer, it is going to mark this route as invalid. Invalid means temporarily not working, or temporarily there is no route in the routing table, temporarily it's not working. So which is what we call as invalid, where it is not removing the information, but it is marking that particular route as invalid, temporarily not working. And how long it is going to be invalid? For 180 seconds. Now in between, if the route comes up, in that case it will receive an update, and it will start forwarding the traffic from that specific route here. So in case if any update comes, if the link comes up here, and it will start using this route if it gets a reply or update on that particular interface. Now in case if there is no update, it's wait for maximum of 180 seconds, and after that it decides to flush or remove the routing information from the routing table. Now how long it is going to wait for that? It's going to use the complete timer of 240 seconds. So which means already it has used 180 seconds here. It's going to wait for 60 more seconds before it decides to flush the information or remove the route from the routing table. Now this is what happens, which means if your best route goes down, in my scenario, this is my best route, which is having 2 hops. If that best route fails due to any reason, it's going to start use the alternate route after 240 seconds, which means after 240 seconds it will remove this route from the routing table, and then it will start using the alternate route or the second best route based on the updates. Okay, so that's what generally happens if there is a network is down. Now there is one more timer we have something called hold on timer. Now hold on timer is something somewhere around 180 seconds, and what happens in the hold on timer is, in general, every router is going to send an update. Let's say the router B says that if you want to go to this router E, you can go from my router, and from my router it is just 2 hops. And the router C advertises that if you want to go to router E, and I have a network, you can go with 3 hops. Now whenever this router advertises, This router is not, it's not going to write that in the routing table. It says I'm going to wait for the hold on time, which means I'm going to wait for 180 seconds, and in this 180 seconds, if you have one more neighbor, it will try to gather the information from all the neighbors, and from this side you are getting 2 hops, from this side you are getting 3 hops, from this side you are getting 4 hops, maybe one more route you are getting 5 hops. It's going to gather the information from advertisements or the updates from all the neighbors, and it's going to select the best one, and it is going to write that particular best route in the routing table, and then whatever the other routes it is going to ignore. So it's going to get all the information in the hold on time. So in the hold on time, it's going to collect the information, and it's going to select the best route, and it will ignore the remaining routes. That's what happens in the hold on time. So hold on time generally happens whenever you configure the RIP for the first time, or if you have multiple routes. If the best route fails, then also the router will go into hold on time, expecting the update from the other routers and selecting any one from the other route. So these are the default timers generally used by RIP for sending the updates. So which means if your main link fails, in my scenario, if I assume that this link goes down, then your alternate link will be up automatically somewhere around after 240 seconds or more than that. Okay, that's a default timer it's going to take for the link to come up. It's going to take more than 4 minutes for the alternate link to come up, and that is something very huge amount of time it's going to take for convergence. Now the meaning of convergence means, what if your best route goes down, this is my best route with 2 hops, right now this route is down, how much time it is going to use for the alternate route to come to forwarding. Now that's what we call as convergence time. Now the convergence time in RIP is very much high when compared with other protocols like EAGRP. It hardly takes 15 seconds for the second link to come up. In case of OSPF, it's going to take just 40 seconds for the alternate link to come up. But in case of RIP, it's more than 4 minutes. So which is something a huge convergence time, and that also one of the disadvantage with the RIP when compared with other protocols. Now I got some definitions here with the timers. Now as I discussed, the time taken between the consecutive updates. Invalid timer, the router waits to hear the updates, and it's going to mark the particular router as unreachable if there is no update is coming during that interval. Flush timer, time before the invalid route is removed from the table. And the hold on timer stabilizes the routing information and helps in routing loop, preventing the routing loops also. So in today's production networks, we generally don't use RIP. So there is one more version which was introduced called version 2, which we use generally, and even that is also not used. Now the major enhancement from version 1 to version 2 is there are some additions, like the version 2 supports classless, which means it is going to carry the subnet mask information along with updates, which means it is going to support your VLSM networks also, like other protocols like EAGRP and RIP, EAGRP and OSPF. And also it supports authentication process, like authentication is beyond the scope of your CCNA exams, but authentication is a method where we can configure a password on both the sides, and we call this as routing protocol authentication. And if the password matches on both the sides, then only we will exchange the updates. If there is a mismatch of the password, then we will not exchange the updates. We will not configure some routing in between us. So that's one more enhancement added in the version 2. And there is one more major enhancement, is it uses a multicast address for identifying the RIP routers on the link with an address called 224.0.0.9, whereas in the version 1 it uses a broadcast address 255.255.255.255 for sending an update, whereas it uses a multicast address for sending an update. So these are the major enhancements in the version 2. Apart from that, everything is same, like the maximum hop counts is 15, and the metric is hop counts, and it supports only up to 16 routers. So mostly almost all the features are same except some few changes. So everything is same. So periodic updates is same, administrative distance remains the same, and the metric remains the same. The only difference is now it has become classless, and there is no updates via multicast, there is no updates via broadcast, it sends via multicast, and also it supports some authentication. Apart from that, all the remaining features still remains the same in RIP version 2. So when we talk about RIP implementations, we generally use only RIP version 2 in today's networks. So probably in our next section, we'll be getting into more in detail on RIP, like how to configure the RIP and how to verify the RIP protocol with labs.